Hello and welcome to my channel. My name is Neha and today's topic is IP version 4. We will discuss IP version 4 with the help of 10 rules. And rule number 1 states that it is a 32-bit address which is divided into 4 octets and each octet carries 8 bits. For example, let's say it is a 32-bit address which is divided into 4 octets, and this is divided by 3 dots as you can see here. Every octet has 8 bits and we have 4 octet here. I'll show you how we will configure IP address on our machines. We will type ncpa.cpl and we'll go to LAN card properties, and then we will go to IP version 4 properties, and here we can assign the IP address. As you can see here, we have 4 octets which is divided by 3 dots. So in this way we will assign the IP address. Now we'll talk about rule number 2. Rule number 2 states for each octet minimum value will be 0 and maximum value can be 255. And that means in every octet value can be between 0 to 255. Now the question arises that why the value is in this range only. So it is because we have 8 bits in every octet, so the minimum value of a bit can be 0. Now if we will convert it into decimal value, it will be like, as you can see here, let's say we have 8 bits, 1, 2, 3, 4, 5, 6, 7 and 8, and I'm going to convert it into a decimal. So it will be 2 to the power 0, 2 to the power 1, 2 to the power 2 and so on till 2 to the power 7. Now if I will convert it into decimal, it will be 2 to the power 0 equals to 1, and 1 into 0 will be 0. Same way, 2 to the power 1 equals to 2, and if we will multiply 2 by 0, we will get the result as 0. And 2 to the power 2 is equals to 4, and 4 into 0 equals to 0. Same way, we'll do it till 2 to the power 7. 2 to the power 7 equals to 128, and 128 multiplied by 0 equals to 0. And by adding all these values, that is 0 plus 0 plus 0, the result which we will get is 0. So now I hope you would have understand that why we will use 0 as a minimum value. Now I'll explain why maximum value can be 255. Now the maximum value of a bit can be 1. So 2 to the power 0 equals to 0. So you can see here 2 to the power 0 equals to 1, and 1 into 1 is equals to 1. Same way, 2 to the power 1 is equals to 2, and 2 into 1 equals to 2, and the value which we will get is 2. 2 to the power 2 equals to 4, and 4 into 1 equals to 4. The same way, 2 to the power 3 is equals to 8, and 8 into 1 equals to 1. We'll do it till 2 to the power 7. 2 to the power 7 is equals to 128, and 128 into 1 is equals to 128. We will sum up all these values, and by adding all these values we will get result as 255. So that's the reason why we will use 255 as a maximum value. Now we'll talk about rule number 3, which states that IP version 4 is divided into 5 different classes. We have class A, B, C, D and E. Class A is from value 0 to 127. Class B ranges between 128 to 191. Class C ranges between 192 to 223. and class D is from 224 to 239, and class E is from 240 to 255. Now we'll come to rule number 4, which states that first octet of the IP address always defines the class. Let's say for an example, I have taken this IP address 109.1.0.1 and its first octet is 109, and 109 is from class A. So the first octet of the IP address always defines the class. That is, the first octet is from class A. Let's take another example, that is 192.168.1.1. 192 is from class C. So this IP address will be from class C. Rule number 5 says that we can only use class A, B and C IP addresses. Reason behind, because class D is used for multicasting and class E is reserved for R&D purpose, that is research and development. Now we'll talk about rule number 6. Rule number 6 states that each and every class have a unique subnet mask. The default subnet mask of class A is 255.0.0.0 and default subnet mask of class B is from 255.255.0.0 and default subnet mask of class C is 255.255.255.0, and there will be no subnet mask for class D and E because we do not use their IPs. Now, what is subnet mask? Subnet mask divides IP address into two different parts, network ID and host ID. So subnet mask will inform us that which part of the IP address belongs to the network ID and which part belongs to host ID. Let's take an example. So for an example, I have taken this IP address 192.168.1.1 which belongs to class C IP address. So its default subnet mask is 255.255.255.0. So this part will belong to network ID and this part will belong to host ID. Same way I have taken another example, that is 10.1.1.1. This belongs from class A IP address. So the subnet mask of this IP address will be 255.0.0.0 and this value, that is this octet, will belong to network ID and this part of the octet or this value will belong to host ID. And one more thing which I would like to add is, while we assign IP address to the machine, we will also assign the subnet mask along with the IP address. Now we'll come to rule number 7, which states that to design a network ID should always be same and host ID should be different. Let's take an example. Let's say we need to design a network and for that we need to attach few computers, and IP address assigned on those computers will be of same network only. Then only they will be able to communicate with each other, else they won't be communicate with each other. Let's say for an example, I am giving this IP address to the machine, that is 171.168.0.1. This IP address belongs to class B. So the default subnet mask of class B is 255.255.0.0. So the next IP which I will be giving to this machine will be 171.168.0.2. The same way next IP I'll be giving will be 171.168.0.3. As you can see here, the network ID remains same. As mentioned in the rule, that network ID should always be same. So this part is the network ID which is same throughout the network, and this part which is host ID it is changing, it is different, it's not same. As long as the machine is in same network, they will be able to communicate. Now we'll talk about rule number 8. Rule number 8 states how to define IP address. Before going further, you need to remember one thing, that we can never assign 0 to first octet because that represents the whole network, and we can never add and we can never identify a network by 0. So we will start with value 1 and we can use value till 223 in the first octet. And the reason why we will use this value till 223 is because we can use IP address till class C only. One more thing which I would like to inform you is that we can't use 127 as IP address. Reason being that 127 is a loopback address which is used to test its own LAN card, that is its self LAN card test. Let's say we have two machines and both the machines are not able to communicate with each other. So how you will check that whether your LAN card is working properly or not? So to check that, we can simply ping the loopback IP, that is 127.1.1.1. Ping 127.1.1.1. So if you will get the response, that means your LAN card is not faulty. There's one more way to check that whether your LAN card is faulty or not. Ping :1. Okay, I'm getting the response, that means my LAN card is not faulty. Or you can ping the localhost if you want to check that whether your LAN card is faulty or not. Or you can ping the self IP address and whatever IP you have given to your computer. And if you will get the response, that means there's no fault in your LAN card. Now let's verify that we cannot use 0 in the first octet. So we'll type command ncpa.cpl and we'll go to Wi-Fi LAN card. We'll go to Wi-Fi LAN card properties. And then I'll go to IPv4 properties. Here I'll try to give 0 value in the first octet. So if you'll type 0, if you'll try to give 0 value in the first octet, you will get this error, and 0 is not a valid entry. Please specify a value between 1 and 2 to 3. Okay. Now let's try to give 224 value in the first octet. So you're getting the error here, that is 224 is not a valid entry. Please specify a value between 1 and 223. But we can use this value in our second, third and fourth octet. Say I've taken an example as 10.0.0.1. So it's taking 0 value in second and third octet, and if I'll try to give 224 value in second and third octet, it will take the value. So I'm not getting the error which I was getting before. So now you know that first IP can't be 0 and last IP can't be 255. So you can see in the first octet we can use value between 1 to 223 only, but in second, third and fourth octet we can use the value between 0 to 255. But sometimes we cannot use 0 and 255 in the last octet. So first IP cannot be 0 and last IP cannot be 255. Okay, let's say for an example, I am giving an IP 20.0.0.0 to a machine where 20 is a network ID and 0.0.0 is a host ID. So we cannot use this IP because we cannot give this IP to a machine because last octet is 0. Let's try and implement this and go to the properties of IPV4. I'll try to give this IP to the machine, that is 20.0.0.0. So if I'll try to give this IP address to the machine, it won't take it. We will get this error that the combination of IP address and subnet mask is invalid. So we cannot use this IP because the last octet is 0. But we can use, let's try to give the another IP address. Let's give it the IP address of 20.1.1.0. Now we won't be getting any error. This machine will take this value. The reason why we are not getting any error, why we are able to implement this IP address to this machine is because this is not our first IP address. So what you have learned so far, that if we have 0 in last octet and if that's the first IP, then it will represent the whole network. That's the network ID. That's the reason we cannot use 0 in the last octet. So sometimes we can use 255 value in last octet and sometimes we cannot use it. If it's in the last octet, then we can't use it because it will be our broadcast address. Now let's say we have two IP address, that is 10.255.255.255. So here I have used 255 in the last octet. So we cannot give this IP to the machine because this will be the last IP of this network. But if we will use this IP, then we can give this IP address to the machine because this won't be our last IP of this network. Now we'll talk about rule number 9. Rule number 9 says how many maximum number of IP address can be in a one network, or maximum number of IP address in one network of any class. Okay, so here I have taken the example of class C IP address 192.168.1.0. So subnet mask of class C is 255.255.255.0. That means this portion belongs to network ID and this portion belongs to host ID. So as you can see, 192.168.1.0, this is our first IP. So we cannot assign this IP address to a machine because this will be our network ID. Our next IP will be 192.168.1.1, and next IP which we will assign to our machine will be 192.168.1.2. As you can see here, network ID is constant and the host ID is changing, and this value will change till 255. So the last IP of this network will be 192.168.1.255, and this last IP will be our broadcast IP. That's the reason we cannot use this IP having 255 value in the last octet. So the IP which we can use will be from 192.168.1.1 till 192.168.1.254. So in total we have 254 IPs which can be used. Now you can see this octet is full. So our next IP will be 192.168.2.0. So now the change will be in this octet, and Since this is the first IP of this network, so this will be our network ID. As you can see here, the network ID has been changed. I hope this example is clear. Let's discuss it with one more example. Now we will take the IP address of class B. Now we will understand with the help of class B IP address. So I have taken this IP as an example 172.16.0.0. This IP belongs to class B and the default subnet mask of class B is 255.255.0.0. So this portion belongs to network ID and this portion belongs to host ID. Now, this is the first IP of this network, so this will be our network ID. And our next IP will be 172.16.0.1. And further, our next IP will be 172.16.0.2. So we will change this value till 255. That is 172.16.0.255. So as you can see, we have this value 255 in our last octet. But this is not the last IP of this network, so this won't be used as a broadcast ID. So we can give this IP to our machine. And now because our last octet is full, so our next IP will be 172.16.1.0. So now we will change in this octet and this value will go on till 255 and this value will go on till 172.16.255.255. So now our third octet is also full and now the change will be in our second octet. So our next IP will be 172.17.0.0. Now you can see the network ID has changed. So this will be our last IP of this network, which will be considered as a broadcast ID. So what will be the number of usable IP for this network? So we can use the IP till 172.16.0.1 to 172.16.0.255, that is 256. So we have got 256 usable IPs and we can use 172.16.1.0 IP till 172.16.255.255, that is the change is from 1 to 255, that is 256. So in total number of usable IPs will be 256 into 256, that will be 65536 number of, that is 65536 usable IPs. But the two IPs will be reserved, that is one for network ID, another one is for broadcast ID. So we'll subtract 2 from this number and we will get 65534 as usable IPs for this network. I hope this is clear now. Now we will talk about rule number 10, which is our last rule, which states that IP address have been divided into two parts. One is private IP and other one is public IP. And private IP address range is further divided into class A, B and C. And class A IP address range is from 10.0.0 to 10.255.255.255 and range of class B is from 172.16.0.0 to 172.31.255.255. And for class C, our range is between 192.168.0.0 to 192.168.255.255. And this is the range for APIPA, A PIPA range is from 169.254.0.0 to 169.254.255.255. There are few differences between private IP and which is private IP is freeware, whereas public IPs are paid. We can use private IP in our local area network, whereas we can use public IP in our wide area network. So that's it for today. I hope you like this video. If you do, then please like this video and share this with your friends and your colleagues. And do not forget to subscribe this channel, and please press on bell icon so that you will be receiving the notifications of my next videos. Thank you for watching.